All right, this is the last problem for paper 2, number 4. It's another triangle problem. You should be getting good at these by now. We've had our share of them. So let's see what's going on. We have a triangle. The lengths of AB and AC are 70 and 50. Everything is labeled on the triangle from the given information. So what I'm going to do is just go in and label like I usually do. Let me grab my pen again. All right, so little a across from big A, little b across from big B, and little c. All right, find the size of angle ABC. ABC, that's this angle up here. So I'm just going to, you always think about law of sines first. Do you have two pairs of opposites? Well, angle B is opposite side B, and angle C is opposite side C, 70. So yeah, you can use the law of sines. So it goes like this. The sine of B over little b, which is 50, equals the sine of C, which is the sine of 78, over C, which is 70. Cross multiply, 50 sine 78 equals 70 sine B. Divide both sides by 70 to get the sine B by itself. Cancels. Go to your calculator, punch in 50 sine 78. Now be sure to close those parentheses. And then divide by 70. And then you're looking for the angle, so you want to hit inverse sine. And if you do that, you should turn up with angle B equals 44.3 degrees. All right, part B. Well, before I get into part B, let me go up here and label that 44.3, because I might want to use that in just a minute. Now, I also might want to use angle A, so I'm going to add 78 and 44.3, subtract from 180, so angle A will be 57.7 degrees. And let me erase this stuff out of here so we can do problem B. Problem B is an area question. So here goes. Now remember, when you use that area formula, 1/2 AB sine C, those letters are really not sacred. All you have to do is pick any two sides and the angle between them. It's got to be a side angle side situation. So if you look at the triangle, two sides with an angle between them, well, we know 70 and 50. So let's use 1/2 of BC sine A, because A is between B and C. So that's 1/2 of B, which is 50, times C, which is 70, times the sine of A, sine of 57.7. And this is a direct punch it into your calculator problem. Just punch it in exactly as it's written, and you will end up with the area. And that turns out to be, I'm getting 1479.2. And that units, we're talking meters, so it's square meters since it's area. Okay, let me erase that off of there. Part C, find the length of BM. From B to M. Well, looking back at the picture, from B to M would be this. Let me try to draw that in. Halfway neat. Yeah, that's not bad. Okay, so if I'm going to try to find that, I'm going to call that X. And notice if you follow the red lines here, that is a triangle. That top part of the big triangle is also a triangle. And I know that from A to M is 25 because it told us that M was the midpoint. So let's see if we've got enough information to find X. Well, X is across from 57.7, but you don't have another angle that's across from the 25 or the 70. So we're going to use law of cosines. So X squared, and then the two sides are 70 on the red triangle, 70 squared plus 25 squared minus 2 times those two angles, which is, or those two sides, 70 times 25, times the cosine of the angle between them, which is 57.7. And again, punch that in exactly as it's written. But don't forget, you got to hit the square root button because that is X squared. And if you do that, let's see, what did I get? I got 60.45. And that's the length So that is meters. Or 60.5, 3 sig figs. All right, the last part. Okay, we just found BM on part C, and you're going to see that that crops up again in part B. In part C we found BM, and now in this next part, 60.45 is BM. So I'm going to come down here and label that before I get into this question. All right, so we have a tower. Does it tell us how tall that tower is? No. It tells us that the angle of elevation from M is 63.4 to the top of the tower. That's labeled. So everything is labeled pretty much. What we want to find is the angle of elevation from N to N from N. So eventually we're after this angle down here. Now the big angle is 63.4, but we're after that angle that cuts it. And it's not cutting it exactly in half. So what we need is, this actually forms a right angle down here. So we can find TB, which is the entire tower, by using the outer triangle. It's just that the tangent of 63.4 is equal to opposite, which is TB, over adjacent, which is 60.45. So you multiply both sides by 60.45 and you'll have TB, and I think TB turns out, see if I've got that written down somewhere, 60.45 times a tan is 63.4. I'm getting 120.71. So TB equals 120.71. But we're after that angle, that little angle down in the corner. So also given was that N is the midpoint. So from B to N, this little section is going to be half of TB. So just take that last answer, divide by 2, and you get 60.35. 60.35 for right there. Now focus on the red highlighted triangle. We're looking for the little angle down in the corner. We know 60.35, we know 60.45, very close numbers. So to find that angle, the tan of that angle down there at M is going to equal the opposite 60.35 over the adjacent 60.45. And again, you are looking for the angle, so you're going to have to use inverse tan. So you go second tan of 60.35 divided by 60.45, and you should get, I'm getting 44.95, and you could round that off to 45.0 degrees. And that is the last answer to the last problem. So that's the end of all the sample problems from your test. Your exam, your mock exam, will look very similar to those types of questions. So if you're pretty familiar with these questions you've seen, you should do well. Good luck.